This is a video on an introduction to the concept of the efficiency of an algorithm. There are two aspects to efficiency, space and time, but we shall look at the aspect relating to time complexity. So the efficiency of an algorithm. Before we understand the term efficiency, we need to understand the term algorithm. An algorithm is a series of steps to solve a problem in a finite amount of time. Let's look at the problems. Memorize the definition of algorithm. It is in your interest. So let us look at problems. A problem could be, how do you get to your house in London, UK, to Seattle, USA? Or it could be something like obtaining the result of adding two numbers. What do we mean by a finite amount of time? Well, finite means you solve the problem in a reasonable amount of time, as opposed to a solution going on and on forever, or for a very long time. The opposite of finite is infinite. And the algorithm has to have a series of steps. So if you get from your house in London, UK, to Seattle, USA, you may 1. Drive to the airport from your house. 2. Catch a flight from London Airport to Seattle Airport. And 3. Drive to the hotel in Seattle. Algorithms can be implemented in a number of ways. Implemented means put into operation or put into practice. These ways include 1. Using flowcharts. 2. Using pseudocode. 3. Using programs. And here is a problem. How can you travel from London, UK to Seattle, USA? Well, 1. You can catch a direct flight. 2. You can walk to the coast of England, then take a boat to the east coast of the USA, and then fly to Seattle. 3. You can walk to the coast of England, take a boat to the east coast of the USA, and then cycle to Seattle. So, quite often there is more than one way of solving a problem. And in this case, the first solution is the most efficient in terms of time, the quickest way, the fastest way, with one step. So, there can be more than one solution to a problem. The same problem can be solved in 2, 3, 4 or more different ways. And similarly, there can be more than one algorithm to solve a computational problem. Let us look at a computational problem. And let us look at two algorithms which solve this particular computational problem, which is summing the first 10 digits. So we want to find the result or the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. This is algorithm 1. And this is a program in Python which implements algorithm 1. So we set the value of sum to 0. We have a loop here, a for loop, and you go round the for loop 10 times. As we have 4j in range 0, 10, you get the output. Print sum is the result of this summation up here. Algorithm 2, and in algorithm 2, you just apply a formula. Sum equals 10 times 10 plus 1, all of this divided by 2. This is one step here, and you print sum, which is the result of this sum, or this problem. So the question is, how many steps does it take for algorithm 1 to solve the problem? Have a look at it again. Algorithm 1, there's a for loop, you go round it 10 times, So it is 10 steps, and it acts on 10 data elements, the data elements being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many steps does it take for algorithm 2 to solve the same problem? Well, it solves it using this equation, doesn't it? So this equation is just one step, and it also acts on 10 data elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, which algorithm is more efficient in terms of time? Think. Algorithm 2. Algorithm 2 takes one step, and algorithm 1 takes 10 steps. So we talk about the efficiency or the time complexity of an algorithm in terms of how many steps an algorithm takes to solve a problem, which is based upon the number of data elements it is acting upon. And it is worth memorizing this whole piece of text here. And when we're talking about efficiency, and here we're talking about time complexity, we're actually talking about how fast an algorithm is. Now please note, there are two forms of efficiency, time and space. In this video here, we're only talking about time. We're talking about time, meaning how fast an algorithm is, which is measured in terms of the number of steps. So that's all for now, folks.